Good evening, friends. Welcome to Unacademy GATE ESE. This is your educator Apuroop, and you are watching the lecture series of machine design. This is lecture number 23, bolted joints. We are almost at the end. Only 3 more chapters left, including bolted joints. Means after this lecture, there will be only 2 more chapters left: gears and springs. Okay. So today we are going to solve a lot of numericals of riveted joints, and then we are going to discuss the design of bolted joints. Design of bolted joint is not very different than design of riveted joints. In fact, a lot of topics are almost similar, but there are few things which you need to learn in case of bolted joints which you have not seen in riveted joints. Okay, so we are going to talk about those topics, and then we are going to solve a lot of numericals of riveted joints also. So please hit the like button right now, and please share the link with your friends. Please share the link with your friends. Good evening, good evening, good evening, guys. One second, something wrong is happening. Is everything okay? Is everything okay? Is everything okay with the audio and video? ऑडियो वीडियो ठीक है? All okay? Okay, so it must be some problem with my video, I think, because मेरे में बहुत फास्ट फॉरवर्ड में चल रहा था. Okay, okay. So everything is okay or everything is fine? Okay. Everything is fine, right? Vikas, Divyanshu, Parth, Kalpesh, everything is okay? चलो ठीक है. So beta, today we are going to solve numericals of riveted joints, and then we are going to move forward to the design of bolted joints. Okay, if you are watching me for the first time, let me introduce myself. My name is Apuroop, all India rank 320 in GATE Mechanical. I've done my MTech from IIT Kharagpur, and my specialization was mechanical systems design. Then in my final year, I was recruited by Mahindra and Mahindra, and I was placed at their research and development center called Mahindra Research Valley, where the cars and tractors of Mahindra are designed. So I worked there as deputy manager in the field of design for 2 years, and then I decided to quit my job and I started teaching. So I've been teaching for more than 6 years now, and I teach subjects related to design: strength of material, machine design, engineering mechanics, and theory of machines. But this is not the reason why I am here. These credentials, my experience, they are not the reason why I am here. I am here in front of you every day because of my love and passion for teaching. And I will always be here in front of you on this very YouTube channel, teaching the subjects of design. Now, if you want to see my lectures of design, you don't need to search anything, you don't need to go anywhere, you just need to open this one link, tinyurl.com/apuroop10. Just open any web browser and type tinyurl.com/apuroop10, and you will go to this page where I have organized all my lectures in one place. You will find Excel sheets of each and every subject that I have ever taught. Strength of material, engineering mechanics, theory of machine, machine design, whatever subjects I have taught, you will find the Excel sheets of each and every subject, and there are video lectures in these Excel sheets, the links of all my lectures, and it is completely free. The entire content is completely free, well organized. If you open any subject's Excel sheet, you will find that I have given the YouTube class link and the PDF link of that class. So everything is well organized. You will understand very easily. All you need to do is just open tinyurl.com/apuroop10. The entire content is completely free of cost. So if you want to prepare these subjects, you don't need to go anywhere else. Just open this link and watch my lectures. You can also download the notes of those lectures. Okay. Now I have a very important announcement to make. I have a very important announcement to make, beta. This week means not this week exactly, from next week means on Monday, Tuesday and Wednesday we have live test of machine design, strength of material and engineering mechanics, and these tests will be on Unacademy. These will be a special class on Unacademy, live test, full syllabus test of machine design, strength of material and engineering mechanics, one by one, on Monday, Tuesday and Wednesday. And what will be the time? 4 p.m. What will be the time? 4 p.m. From 2 p.m. you have crash course on theory of machine, special class on crash course on theory of machine, and then on 4 p.m. from Monday, Tuesday, Wednesday, you will have live full syllabus test of machine design, strength of material and engineering mechanics. Okay, and how you can access these classes? All you need to do is follow my Unacademy profile. Follow my Unacademy profile. If you open my Unacademy profile, you can watch all my special classes at one place. मेरी सारी special classes एक जगह आप देख सकते हैं. And beta, all these classes are completely free of cost. What to do, beta? If you want to watch these classes, download the Unacademy learning app, register yourself, and then use the invite code Apuroop10. If you are watching the special class for the first time, you will have to put an invite code which will be Apuroop10. Okay. So beta, on Monday, Tuesday and Wednesday, you have special class, live full syllabus test of machine design, strength of material and engineering mechanics. But before that, tomorrow you have a marathon, 5 hours marathon class on dynamics of particle and rigid body. कल सुबह 9 बजे on YouTube. कल सुबह 9 बजे on YouTube, on this channel, you have a 5 hours marathon class on a dynamics of particle and rigid body. So don't forget to tune live to see this marathon class. Beta, your complete dynamics portion will be revised. आपका पूरा dynamics portion जो है मेरे साथ revise हो जाने वाला है. आपका पूरा dynamics जो है वो मेरे साथ revise हो जाने वाला है मेरे भाई. तो आप कल सुबह 9 बजे live आना ना भूलें. Tomorrow at 9 a.m. live with me for this 5 hours marathon session on dynamics of particle and rigid body. Okay, entire dynamics will be revised, all the concept behind dynamics, all the numericals of dynamics, all the previous year gate questions of dynamics. Beta, everything related to dynamics will be completed in this 5 hours session. Okay, and I have another very good news for you, beta. We will complete the entire syllabus of machine design on 30th of December. 30 दिसंबर को मशीन डिजाइन की आखिरी क्लास होने वाली है. There will be last class of machine design on 30th of December, and on 31st of December, on the last day of this year, we have 8 hours marathon session on complete revision of machine design. 8 घंटे की लगातार क्लास जिसमें I will revise the complete machine design. I will give you the important formula. We will see 1 or 2 very important examples, and beta, your short notes of machine design will be completed. Your short notes of machine design will be prepared in this 8 hours marathon session. तो ये 8 घंटे की मैराथन सेशन देख लो और आपका पूरा मशीन डिजाइन रिवाइज हो जाने वाला है. ओके, ऑन 30th of December we will complete machine design, and on 31st of December, on the last day of this year, इस साल का आखिरी दिन, और हम 8 घंटे की मैराथन क्लास करने वाले हैं जिसमें हम पूरा मशीन डिजाइन खत्म कर देंगे. We will complete the entire machine design together. Okay, and your short notes of machine design will be prepared. आपका short notes prepare हो जाने वाला है बेटा. So beta, these are the classes that I am going to take until 31st of December. 31 दिसंबर तक ये मेरी क्लासेस हैं. Tomorrow 5 hours marathon session, Sunday 5 hours marathon session, then Monday, Tuesday, Wednesday live test of machine design, strength of material, engineering mechanics. Okay, it will only take 1 hour. 1 घंटे का टेस्ट होने वाला है. 4 बजे चालू होगा, 5 बजे खत्म हो जाएगा. Okay, and then on 31st of December we will have 8 hours marathon session on complete revision of machine design. 30th of December will be the last class of machine design, and on 31st December we will complete entire machine design in this 8 hours marathon session. So I hope all of you are happy about these classes, and if you are happy about these classes, let your friends know about this. Okay, where you will find the links of all these classes. In सबकी link कहाँ मिलेगी? How I will get to know when to take these classes? कहाँ से link पाऊंगा मैं? So बेटा, all you need is follow my Telegram channel. Follow my Telegram channel. I will share the notification and links in this Telegram channel. इस Telegram channel में सारी चीजें मैं पोस्ट करता रहता हूं. Personally, I post the links of all my classes. So बेटा, follow this Telegram channel, or you can also go to tinyurl.com/apuroop10. Here also there will be links of all the classes. Okay, so beta, don't forget about these classes. Okay, tomorrow 5-hour marathon session, then on Monday, Tuesday, Wednesday live test, and then on Thursday 31st of December 8-hour marathon session on machine design. Okay, so this is my gift for you for this new year. ये मेरा न्यू ईयर गिफ्ट है आप लोगों के लिए. 31 दिसंबर खत्म होते होते मैक्सिमम हम जितनी क्लासेस एक साथ कर सकते हैं वो सब कर लेते हैं बेटा. देन जनवरी के महीने में आई विल ब्रिंग न्यू प्लान्स, एंड देन वी विल स्टार्ट अनदर सब्जेक्ट, वी विल स्टार्ट अनदर क्लास. ठीक है, जनवरी के महीने में नया क्लास, नया साल, नए तरीके की प्रिपरेशन. ओके, सो आई होप ऑल ऑफ यू आर वेरी इंटरेस्टेड इन दीज क्लासेस. चलो, and beta, very important news for all the GATE 2022 and 2023 aspirants. Beta, only few days left in order for you to enroll in these two awesome batches. 28th of December say these batches are going to start on Unacademy Plus. Evolve batch for GATE 22 and Ascend batch for GATE 23. And what is so special about these batches? In batches में ऐसा क्या खास है sir? So beta, the most important thing that you need to understand is that only the best of the best educators will be taking these classes. Means for every subject you will have a specialized faculty. आपको हर एक सब्जेक्ट के लिए एक स्पेशल एजुकेटर मिलने वाला है, एक एक्सपीरियंस एजुकेटर मिलने वाला है, दी बेस्ट एजुकेटर मिलने वाला है. ओके, सो ऑल दी बेस्ट एजुकेटर्स ऑन Unacademy Plus will be coming together for these two batches. So if you want to learn from the best, if you want to learn among the best, then beta, take Unacademy Plus subscription using the code Apuroop10. Now, why do you need to take Unacademy Plus subscription and how it is going to help you? That I will discuss at the end of the lecture. Okay, so if you want to take Unacademy Plus subscription, all you need to do is go to unacademy.com or Unacademy learning app, and then choose which plan you want to take. I will suggest you take 1 year, 1.5 year or 2 year plan, but don't forget to use this code Apuroop10 in order to get 10% off on your subscription plan, and in order to get my personal guidance and my mentorship. Okay, so I will see you soon on Unacademy Plus in these two batches. And you can also take Unacademy Iconic subscription using the same code. आप यही कोड लगा के Unacademy की Iconic subscription भी ले सकते हैं, where you are going to get a personal guide, a personal coach who will always push you towards your goal, who will help you to achieve your goal. Okay, on a very personal level. Okay, now let's start first our marathon session on the numericals of riveted joints. सबसे पहले तो riveted joints के marathon session चालू करते हैं, and then बेटा we will move on to the design of bolted joints. ठीक है, पहले हम riveted joints के सारे numericals बना लेते हैं, फिर हम bolted joint के डिजाइन में जाएंगे. So this is the first question of riveted joints in front of you. A steel bar of 10 mm into 50 mm is cantilevered with two M12 bolts. Now this is a question of bolted joint. So what is it doing here? But I told you, eccentric loading का question, bolted joint हो या riveted joint हो, it is going to be solved in the same way. Okay, but what is this M12? M12 का मतलब क्या है? M12 bolt means diameter is 12 mm. ठीक है, M12 लिखा है मतलब diameter क्या है? 12 mm. So this is a question from GATE 2008. Okay, so beta, we have a plate which is bolted to another plate by means of two bolts of 12 mm diameter. There is a static load of 4 kN acting as shown in figure. The resultant shear stress on bolt P is closest to. You need to find the resultant shear stress on bolt P. So how you are going to calculate this stress? ये वाला stress आप कैसे निकालने वाले हो? Let's understand. Okay. So beta, in order to calculate the resultant stress, first I will calculate the primary and secondary force. फर्स्ट आई विल कैलकुलेट द प्राइमरी एंड सेकेंडरी फोर्स. अब बेटा सेंट्रॉइड कहां पे आने वाला है? वेयर आई विल गेट द सेंट्रॉइड? आई विल गेट द सेंट्रॉइड हियर बिटवीन P एंड Q. तो P से कितने डिस्टेंस पे आने वाला है? P से कितने डिस्टेंस पे आने वाला है? द डिस्टेंस विल बी 0.2 मीटर. दिस टोटल डिस्टेंस इज 0.4, so the distance will be 0.2 मीटर. ठीक है. देन बेटा प्राइमरी फोर्स P dash is going to be what? P by 2. P dash will be P by 2, means 2 kilonewton, and secondary force will be C into R. Now what will be the constant beta? PE upon R1 square plus R2 square. So it will be 4 kilonewton into E. E कितना है मेरे भाई? यहाँ सेंट्रॉइड से लेके यहाँ तक का डिस्टेंस, what will be the total distance? From here to the load, what will be the total distance? It will be 2 meter, right? So beta P into E divided by इसका सेंटर से डिस्टेंस का स्क्वायर प्लस इसका सेंटर से डिस्टेंस का स्क्वायर. So this will be 0.2 square plus 0.2 square. This is C multiplied by 0.2. This is R. Okay. So C into R will give me the secondary force. तो secondary force कितना आ रहा है? 20. Secondary force is 20 kilonewton. So primary force is 2 kilonewton and secondary force is 20 kilonewton. So what will be the resultant force now? Understand. In order to calculate resultant force, first I need to find the direction of primary and secondary force. So primary force will be opposite of force. ये हो गया आपका primary force. Primary force. अब secondary force का direction कैसे देखते हैं? If I want to find direction of secondary force here, I will join this point with the centroid. So I will get a horizontal line. Now secondary force will be perpendicular to this. Now primary force, the moment of this 4 kilonewton will be clockwise. Moment of this will be clockwise. So secondary force should be anti-clockwise. तो बेटा इस point पे anti-clockwise moment कैसे आएगा? When the secondary force will be acting like this. So beta primary force is upward, secondary force is downward. So what will be the total force? What will be the second resultant force? P resultant will be equals to 20 minus 2, यानी कि 18 kilonewton, right? P resultant will be this minus this. Both are vertical, but one is downward, one is upward. So 20 minus 2, 18 kilonewton. Now shear stress on P will be equal to what beta? Load upon area. So load is this and area will be pi by 4 d square. And what is the diameter? 12 mm. It is a 12 bolt. So diameter ले लो 12 mm. So how much stress are we getting? 18 kilonewton into divided by area. 159 point something megapascal, right? Around 159 megapascal आ रहा होगा. You must be getting around 159 megapascal. Around 159 megapascal. So this is the stress in the rivet number P. 159 megapascal. Yes. Very good Palak. Very good Kalpesh. Very good Jitendra. Very good Akshay. Very good Ayush. Very good. Very good. बहुत बढ़िया दोस्तों, बहुत बढ़िया. तो बेटा प्राइमरी एंड सेकेंडरी फोर्स का डायरेक्शन इज वेरी इंपॉर्टेंट. ओके, प्राइमरी एंड सेकेंडरी फोर्स का डायरेक्शन इज वेरी इंपॉर्टेंट. बेटा दोज ऑफ यू हु आर लाइव, प्लीज हिट द लाइक बटन एंड डोंट फॉरगेट टू शेयर द लिंक. शेयर द लिंक, शेयर द लिंक. ओके, थैंक यू सो मच इफ यू हैव ऑलरेडी डन दैट. वेरी गुड स्वेक्षा, वेरी गुड अंकिता, वेरी गुड दिव्यांशु, प्रेम, वेरी गुड. 159 megapascal. Very good. चलो. So beta, I told you yesterday, eccentric loading in riveted joint is very important from exam point of view, right? चलो. तो next question देखते हैं. So this is the next question, beta. This is also from GATE 2013. This is, I think, as far as I remember, GATE 2013 का question. Okay, I forgot to mention. A single riveted lap joint of two similar plates, as shown in figure below, has following geometrical and material details. Width of the plate is 200 mm, thickness of the plate is 5 mm, number of rivet is 3, diameter of rivet is 10 mm, and diameter of hole is 11 mm. I told you there might be some gap between hole surface and rivet surface. So diameter of rivet is 10, diameter of hole is 11. Then allowable tensile stress of plate is 200, allowable shear stress is 100, and allowable bearing stress of rivet is 150. If the rivets are to be designed to avoid crushing failure, maximum permissible load is. तो बेटा rivets के crushing से अगर मैं load निकालूं, then what will be the load? What will be the crushing strength of rivet? Crushing strength निकालो मेरे भाई, PC का फॉर्मूला लगा दो. What was the equation of PC? What was the equation of PC? Equation of PC was R into N into D into T into sigma C. This was the equation of PC. ये क्या हो गया? This was the equation of PC बेटा. R into N means total number of rivets. तो total number of rivets तो यहाँ 3 है. Diameter of क्या लेंगे यहाँ पे? Here I am calculating crushing strength of rivet. So I will take the diameter of rivet. So diameter of rivet is 10 mm. Thickness of plate is 5 mm. And sigma C is 150. So how much PC I will get? How much PC I will get? How much PC I will get? 22.5 kilonewton. Very good. This will be 22.5 into 10 to the power 3 Newton or 22.5 kilonewton. Very good. Very good. Very good Palak, Jitendra. Very good Ankita. Very good Kalpesh. 22.5 kilonewton. Very good Prem. 22.5 kilonewton. So this was a question from GATE 2013. But beta, there was another question based on the same data. This is known as common data question. Nowadays, you don't see these types of question, but earlier we used to get these type of question. Common data. There will be common data. There will be 2 questions based on the same data. So beta, same data, but this time the plates are to be designed to avoid tearing failure. Okay. So beta, PT निकालो. अब now you need to calculate PT. Now you need to calculate PT. Very good Zubair. Very good Parth. Very good Saurabh. Very good Dibyanshu. Very good Akshay. Very good Prem. Very good Sweksha. चलो, now you calculate PT. अब PT निकाल लो मेरे भाई. PT calculate करो. Tearing failure of plate avoid करनी है. What will be the maximum applicable load? Calculate it. Calculate it. PT. Same data, but this time you need to find PT. वही डेटा यूज करना है, बट इस बार PT निकालना है. Calculate PT. What will be PT? PT will be equal to what? PT will be W minus ND into T into sigma T. And beta, here I will consider the diameter of hole because I am considering the plate. So beta, यहाँ पे W is how much? Width is 200. Number of holes 3. Diameter of hole 11. Thickness 5. And sigma T is 200. So how much is PT? PT कितना है? How much is PT? 16.7 kilonewton. 16.7 की 167. 167. Yes, 167 kilonewton. 167 into 10 to the power 3 Newton, or I can say 167 kilonewton, right? 167 kilonewton. Very good Ankita, Palak, Jitendra. Very good Kalpesh. Very good. 167 kilonewton. Very good Akshay. Very good Parth. 167 kilonewton. 167 kilonewton. Very good Prem. Very good Zubair. Very good Ayush. 167 kilonewton. 167 kilonewton. This will be the maximum permissible load to avoid tearing failure. Very good Utkarsh, Divyanshu, Sweksha. Very good Nitish. Very good. Very good. So beta, these two are the questions in GATE 2013. Okay. Next, आगे बढ़ते हैं. Shall we move forward? आगे बढ़े. चलो. Next question again on eccentric loading. This is from GATE 2015. ये GATE 2015 का question है. A cantilever bracket is bolted to a column using 3 M12 bolts. M12 बोल दिया मतलब diameter is 12 mm. and don't worry about the bolt beta. Even if it is a bolt or a rivet, the procedure will remain same. The value of maximum shear stress in the bolt is, in the bolt P is, इस बार bolt P में maximum shear stress निकालना है. Okay. Now beta, there are three bolts P, Q and R equally placed. तो बेटा equally placed मतलब sorry, दोनों में तीनों में same space है, equally spaced. तो बेटा centroid कहाँ पे आएगा? If all three are equally spaced, I will get the centroid on Q. Q पे ही, Q के center पे ही centroid आएगा. तो बेटा what will be the primary force here? Primary force क्या हो जाएगा? Primary force will be force upon number of rivets. Force is what? 9 kilonewton divided by number of rivets 3. So primary force is 3 kilonewton. Secondary force will be C into R. And what is C beta? PE upon R1 square plus R2 square plus R3 square. P is 9 kilonewton. E is 250 divided by R1. P से लेके सेंट्रॉइड डिस्टेंस 30, R2 Q से लेके सेंट्रॉइड डिस्टेंस 0 because Q and centroid are at the same point, and R3 R से सेंट्रॉइड का डिस्टेंस again 30. So this is C multiplied by R means 30. So what is the value of P double dash? P double dash कितना आ रहा है? What is P double dash? What is P double dash? What is P double dash? $37.5 kilonewton. Is it 37.5 kilonewton? Yes. So beta, now I know that primary and secondary force magnitude is 3 and 37.5. But I want to find the resultant. So how I will find the resultant? Look at the direction. So primary force will be opposite of this force. So primary force ka direction will be upward. Primary force direction will be like this, upward. Okay. But secondary force, how to find the direction of secondary force? So understand, I need to find direction of secondary force at this point. So इस point को centroid से मिलाया, so I will get a vertical line, right? Now perpendicular to this line will be a horizontal line. So beta, secondary force will be horizontal. Now this force is applying clockwise moment. So secondary force should apply anti-clockwise moment, means secondary force will be like this. Okay. Now if primary force and secondary force are perpendicular to each other, then what will be their resultant? उनका resultant कैसे निकलेगा मेरे भाई? P resultant will be equal to root over 3 square plus 37.5 square. So what is the resultant? 37.6 root over 3 square plus 37.5 ka square. So 37.62 kilonewton. 37.62 kilonewton. Yes. So beta, 37.62 kilonewton is the resultant force. Now I need the stress. So 37.62 into 10 to the power 3 divided by pi by 4 into 12 ka square. So what is the maximum shear stress? What is the shear stress? $332.45 megapascal. Is it 332.45 megapascal? Are you getting this much stress? 332.45 megapascal. Are you getting this? Are you getting this? Come on, tell me. Yes, Ayush, very good, Jitendra. Yes, Kalpesh, 332 point something. Yes, very good, Akshay, very good. What about the other people? Very good, Nitish. Very good, Parth. Very good, Dibyanshu. Very good, Gopala Krishna. Very good, Prem. Very good, Gopala Krishna. Very good, Sweksha. Very good, Ankita. Very good, Jitendra. 332 point something megapascal. Very good Brijesh. 332 point something megapascal. इसी बात पे जिन्होंने भी अभी तक लाइक बटन नहीं दबाया है, प्लीज हिट द लाइक बटन एंड शेयर करो बाबा, शेयर करो. वेरी गुड ब्रिजेश, वेरी गुड. चलो तो बेटा अनदर एसेंट्रिक लोडेड क्वेश्चन फ्रॉम गेट 2015. ये गेट 2015 का क्वेश्चन है. ओके, so shall we move on to the next question? Next question is this. A triple riveted double strap butt joint has 4 rivets in each row. Width of the plate is 100 mm and thickness of the plate is 10 mm. Diameter of shank of rivet is 12 mm. Tensile strength of the material is 200 megapascal. Compressive strength is 140 megapascal and shear strength is 100 megapascal. Find the maximum applicable load on the plates and the joint efficiency. Solve this problem beta, solve this problem. Solve this problem. Find the maximum applicable load and joint efficiency. Maximum applicable load निकाल लो और joint efficiency निकाल लो. So what you will do to find maximum applicable load? In order to find maximum applicable load, you need to first calculate PS, PT, PC separately. We have a triple riveted double strap butt joint. तो बेटा तीनों निकाल लो, PS, PC, PT. Come on. सबसे पहले we will calculate PT. Okay. You need to remember the formula. That's it. आपको formula याद होना चाहिए. तो here they have given the entire width. तो per pitch length वाला formula नहीं, पूरे width वाला formula. W minus ND into T into sigma T. Okay. तो बेटा what is W? W क्या है? W is कहाँ गया? 100 mm minus N. So what is N? It is a triple riveted. तो बेटा N will be 3. Diameter of hole or rivet is 12. Thickness is 10. Sigma T is 200. So how much is PT? PT कितना आ रहा है? How much is PT? 128 kilonewton. I hope everyone is getting this. 128 kilonewton, right? PT is 128 kilonewton. Then PS, R into N, total number of rivets into pi by 4 D square. But this is a double strap butt joint. And in case of double strap butt joint, the area will be 2 times. तो इसका 2 times कर दो मेरे भाई into tau. तो मेरे भाई क्या आ रहा है? Number of rows is what? Number of rows is, oh sorry. Number of rows is 3. Number of rivet is 4. ये 4 होना चाहिए. This must be 4. ठीक है? Yes, this must be 4. गड़बड़ कर दी मैंने. I have made the mistake. गड़बड़ कर दी है मैंने. Number of rows are 3, but number of rivet in each row are 4. ठीक है? So if you have made the same mistake, please correct yourself. So this will be 104 kilonewton. This will be 104 kilonewton. If you have made the same mistake, beta, please correct yourself. Yes, Palak, N is 4. Yes, Jitendra, 104 kilonewton. Okay. Now PS will be how much? Number of rows are 3. This is the number of rows. Triple riveted means R is 3 and 4 rivets in each row matlab N is 4. Okay. So 3 into 4 into pi by 4 into 12 square multiplied by 2 into tau. Tau is 100. So how much is this PS? PS कितना आ रहा है? $271.43 is PS 271.43. 271.43 kilonewton, 271.43 kilonewton, yes. And then PC will be R into N into D into T sigma C. R into N into D into T sigma C. तो number of rows 3, number of rivets N4, D is 12, T is 10 and sigma C is 140. So how much is PC? (201.6) into 10 to the power 3 Newton, right? 201.6 into 10 to the power 3 Newton. Very good, very good. Prem, Kalpesh, Jitendra, Palak, Ayush, Ankita, Divyanshu. Very good, Parth. Very good. तो बेटा अब आपको PS, PT, PC तीनों मिल चुका है. Which one is the minimum one? This one is the minimum one, right? This one is the minimum one. तो मेरे भाई this one will be the answer, okay? तो P will be equal to minimum of PS, PC and PT. So maximum applicable force P will be 104 kilonewton. This will be 104 kilonewton, right? Very good. 104 kilonewton. Yes, 104 kilonewton. अब मेरे भाई, now I need to calculate the joint efficiency. So what is joint efficiency? Joint efficiency is minimum of PS, PT and PC divided by W into T into sigma T. This was the equation of joint efficiency. This was the equation of joint efficiency. Yes, very good. तो बेटा joint efficiency में ऊपर क्या आ जाएगा? This will be 104 kilonewton divided by W means 100 into T into sigma T. So how much joint efficiency are we getting? How much joint efficiency are we getting? .52 और 52%. 0.52 या आप बोल सकते हो 52%. 0.52 और 52%. वेरी गुड पलक, वेरी गुड अक्षय. 0.52 और 52%. वेरी गुड कल्पेश, वेरी गुड प्रेम. Very good guys, very good. 52% means 48% reduction in load carrying capacity. 48% reduction. Very good Ankita, very good Zubair, very good Jitendra, very good Divyanshu. 52%. 52% is the joint efficiency. Okay, so shall we move on to the next question? Very good Sveksha, very good Nitish, very good. Shall we move on to the next question? चलो next question की तरफ चलते हैं. So again this question is a very interesting question and let me tell you that this is an MSQ. ये एक MSQ question है, ठीक है? This is an MSQ question. MSQ question है मेरे भाई. Okay, so a riveted joint has been designed to support an eccentric load P. Okay, the load generates value of F1 equal to 4 kilonewton and F2 equal to 3 kilonewton. Cross sectional area of each rivet is 500 mm square. Which of the following statements are correct? इनमें से कौन सा statement correct है? एक सेकेंड, लास्ट स्टेटमेंट दिख नहीं रहा है. I think now it is visible. Okay, now it is visible. So which one is correct? So beta, understand what is given. The first statement is the stress in the rivet is 10 Newton per mm square. Value of eccentricity is 100 mm. Value of load is 6 kilonewton and resultant force is 6 kilonewton. तो बेटा इनमें से कौन कौन सा करेक्ट है? F1 is 4 kilonewton and F2 is 3 kilonewton. ओके, तो बेटा आपको बताना है इनमें से कौन सा सही है. ओके, तो सबसे पहले F2 is what? प्राइमरी फोर्स. F2 is opposite of the force. तो F2 जो है वो प्राइमरी फोर्स है एंड प्राइमरी फोर्स multiplied by number of rivets will give you the total force. Total force divided by number of rivets is primary force. So primary force number into number of rivets is total force. तो primary force कितना है 3 kilonewton multiplied by 2, total force कितना होगा 6 kilonewton. तो बेटा total force is 6 kilonewton. So this is true. ये तो correct है. This is correct. Okay. Then बेटा the resultant force is 6 kilonewton. तो this resultant force 6 kilonewton आएगा क्या? Understand. Primary force is 4 kilonewton. Secondary force is 3 kilonewton. So beta, how the resultant force will be 6 kilonewton? Resultant will be what? Resultant will be what? F resultant will be root over 3 square plus 4 square. So resultant force will be 5 kilonewton. So this is not true. The resultant is not 6 kilonewton, it is 5 kilonewton. Okay. So beta, अब stress in the rivet is 10 Newton per mm square. तो stress 10 Newton per mm square है क्या? Resultant force divided by area कर लो. तो resultant force divided by area is 10 megapascal or 10 Newton per mm square, right? Tau will be F resultant divided by area. So 5 kilonewton divided by 500 means 10 Newton per mm square. So the stress is 10 Newton per mm square. But eccentricity is 100 mm. अब eccentricity 100 mm है क्या? कैसे पता चलेगा? In order to find eccentricity, what equation you can use? Secondary force will be equal to what? C into R1 means P into E by R1 square plus R2 square into R1. अब इस equation में I have F1, I have P, but R1, R2 and E, all three are unknown. तो क्या ये कभी निकलेगा? क्या ये कभी निकलेगा? क्या ये कभी निकलेगा? क्या ये कभी निकलेगा? नहीं, eccentricity नहीं बता सकते कि 100 mm है. This is not true. So beta, answer will be A and C. A and C. Answer will be A and C. Yes, eccentricity is not necessarily 100 mm. Eccentricity is not necessarily 100 mm. Eccentricity कुछ भी हो सकती है. If you have the distance between rivets, then only you will be able to calculate the eccentricity, right? अगर आपको rivets के बीच का distance दिया होता तब eccentricity निकलती, but अभी नहीं निकलेगी. Right now you cannot say eccentricity is 100 mm. So a beautiful MSQ question, एक बहुत खूबसूरत MSQ question, right? चलो नेक्स्ट क्वेश्चन की तरफ चलते हैं. नेक्स्ट क्वेश्चन की तरफ चलते हैं. यस, वेरी गुड गाइस, वेरी गुड, वेरी गुड. नेक्स्ट क्वेश्चन की तरफ चलते हैं. नेक्स्ट क्वेश्चन इज अगेन based on eccentric loading. A riveted joint consisting of two identical rivets is subjected to an eccentric force of 15 kilonewton as shown in figure. Determine the diameter of rivets if the permissible shear stress is 60 megapascal. How you will get the diameter? You need to find the equation of tau maximum. पहले tau maximum की equation बनानी पड़ेगी. From that equation we will get the diameter. Okay. So again another question of eccentric loading. Now beta, where you will get the centroid? Where you will get the centroid? Where you will get the centroid? Centroid कहां पे आएगा मेरे भाई? Centroid कहां पे आएगा? This is rivet number 1, this is rivet number 2. So where you will get the centroid? Between rivet number 1 and 2. यहां कहीं पे you will get the centroid. Okay. Now centroid से both the rivets are at the same distance. दोनों रिवेट सेंट्रॉइड से सेम डिस्टेंस पे हैं. तो बेटा वेयर यू विल गेट मैक्सिमम रिजल्टेंट. अब रिजल्टेंट कहां मैक्सिमम आएगा? तो प्राइमरी फोर्स ऑन बोथ द रिवेट्स विल बी अपवर्ड ओनली, P1 डैश P2 डैश. अब सेकेंडरी फोर्स का डायरेक्शन कैसा होगा? दिस विल बी द लाइन ज्वाइनिंग रिवेट्स एंड सेंट्रॉइड. सेकेंडरी फोर्स विल बी परपेंडिकुलर टू दिस लाइन. नाउ द मोमेंट ऑफ दिस फोर्स विल बी एंटी क्लॉकवाइज. इस फोर्स का मोमेंट कैसा आएगा? मोमेंट ऑफ दिस फोर्स विल बी एंटी क्लॉकवाइज. सो सेकेंडरी फोर्स विल बी क्लॉकवाइज. तो बेटा 2 पे सेकेंडरी फोर्स कैसा आएगा? 2 से लेके G तक क्लॉकवाइज आना है. 2 से लेके G तक क्लॉकवाइज आना है. सो दिस विल बी सेकेंडरी फोर्स का डायरेक्शन ऑन रिवेट नंबर 2. 2 से लेके G तक क्लॉकवाइज आओ मेरे भाई. 1 से लेके G तक क्लॉकवाइज आना है. 1 से लेके G तक क्लॉकवाइज आना है. तो दिस विल बी द डायरेक्शन ऑफ सेकेंडरी फोर्स इन रिवेट नंबर 1 क्लॉकवाइज. मोमेंट ऑफ दिस फोर्स विल बी एंटी क्लॉकवाइज. तो मोमेंट ऑफ सेकेंडरी फोर्स शुड बी क्लॉकवाइज. ओके, तो मेरे भाई अब यहां पे ध्यान दो. P2 में सेकेंड रिजल्टेंट विल बी P2 डबल डैश माइनस P2 डैश एंड 1 में रिजल्टेंट विल बी P1 डैश प्लस P1 डबल डैश. सो वेयर रिजल्टेंट विल बी मैक्सिमम ऑब्वियसली इन रिवेट नंबर 1. रिवेट नंबर 1 में रिजल्टेंट सबसे ज्यादा होने वाला है. तो मेरे भाई रिजल्टेंट रिवेट नंबर 1 का कैलकुलेट करो. P1 dash will be equal to how much? P1 dash कितना होने वाला है? What will be P1 dash? P1 dash will be force upon number of rivets 7.5 kilonewton. P1 double dash C into R1. C into R1. C मतलब P into E by R1 square plus R2 square. P is 15. E is how much? यहां से यहां तक का डिस्टेंस कितना होगा? 50 mm. 4 से लेके G तक का डिस्टेंस 50 डिवाइडेड बाय R1 स्क्वायर प्लस R2 स्क्वायर. दोनों का डिस्टेंस 50. तो 50 स्क्वायर प्लस 50 स्क्वायर. सो दिस इज C multiplied by R1 50. So how much P1 double dash are we getting? How much P1 double dash are we getting? 7.5 kilonewton only. 7.5 kilonewton only, right? P1 dash and P1 double dash both are 7.5 kilonewton. So P resultant will be P1 dash plus P1 double dash मतलब 15 kilonewton. हाँ कि ना? 15 kilonewton. P1 dash plus P1 double dash both are 7.5. तो resultant 15. Now tau maximum will be P resultant of rivet number 1 divided by area of rivet. Okay, so tau maximum is given 60 megapascal. P resultant is 15 kilonewton divided by pi by 4 d square. So from here you will get the minimum required diameter of the rivets. तो क्या आएगा मेरे भाई? Are we getting 17.84 mm? Very good, Palak. 17.84 mm. 17.84 mm. 17.84. Very good, Jitendra. 17.84 mm. 17.84 mm. So minimum required diameter of the rivets is 17.84 mm. Is this clear? Is this clear? Yes, Nitish. Very good, Ayush. Very good, Utkarsh. Very good, Gopal Krishna. Very good, Kalpesh. Very good, Dibyanshu. Very good, Prem. Very good, Ankita. 17.84 mm. You guys have become the masters of eccentric loaded riveted joints. Eccentric loading के master बन गए हो अब आप. I think if you know the how to find the direction of primary and secondary force, means almost every question you can solve. Every question you can solve, right? Very good, Parth. अगर आपको डायरेक्शन निकालना आ गया प्राइमरी सेकेंडरी फोर्स का, उसके बाद आपको कुछ करने की जरूरत ही नहीं है. द प्रोसेस इज ऑलमोस्ट सेम इन एवरी केस. प्रोसेस तो हर किसी केस में वही है. Only direction changes in every question. Direction changes. Very good, Zubair. Very good. चलो next question देखें. Shall we move forward to the next question? Next question is, if the ratio of diameter of hole to the pitch of rivet is 0.25, then the tearing efficiency of the joint is, if the ratio of diameter of hole to the pitch of rivet is 0.25, अगर diameter of hole और pitch of rivet के बीच में ratio 0.25 है, then tearing efficiency is, what is tearing efficiency? Joint efficiency is minimum of PS, PT, PC divided by WT sigma T. But tearing efficiency means ऊपर minimum of PS, PT, PC नहीं करेंगे, ऊपर will be PT. Tearing efficiency पूछा तो ऊपर tearing load ले लो, divided by W into T into sigma T. अब फॉर्मूले में वैल्यू रख दो, PT is what? W minus ND into T sigma T divided by W into T sigma T. अब T sigma T कैंसल. अब यहां पे देखो बेटा, पिच की बात कर रहा है, पिच दिया हुआ है. So whenever pitch is given, I told you what you need to do. You need to replace W with P and N with 1. तो अगर मैं W को P से और N को 1 से रिप्लेस कर दूं, then this one will become P minus D by P. P minus D by P, or I can say 1 minus D by P, right? And what is D by P? 0.25. So what is tearing efficiency? 0.75. Yes. Very good Palak, very good Jitendra, very good Prem, Kalpesh, very good Akshay, very good Ankita, very good Parth. The answer will be 0.75. Tearing efficiency will be 0.75. Is this clear? तो यहां दो चीजें देखने को मिली. First, tearing efficiency is what? If tearing efficiency is asked, then use PT. If joint efficiency is asked, use minimum of PT, PC, PS. Okay. Second thing, if pitch is given, replace W with P and N with 1. W को P से replace कर दो, N को 1 से replace कर दो, and you will get your answer. Okay. Very good Vamsi, very good. Very good Dibyanshu, very good Jitendra, very good Shailesh, very good Sweksha. Very good. चलो. Next question बेटा. अच्छा ये वाला question we have solved. We have already solved this yesterday. Next question from GATE 2016. GATE 2016 का question है. A bolted joint has 4 bolts arranged as shown in figure. Bolted joint का question है, but don't worry बेटा. It will be just solved just like riveted joint. Okay. So a bolted joint has 4 bolts arranged as shown in figure. Cross sectional area of each bolt is 25 mm square. Torque is 200 Newton meter. Neglecting friction due to clamping force, maximum shear stress in bolt is. Understand beta, we have 4 bolts. 1, 2, 3 and 4. And there is a torque acting at the center of the bolt. Okay. इसको मैं और अच्छे से समझाता हूं. Okay. We have 4 bolts arranged in a circular path. 4 बोल्ट है मेरे भाई, उनको सर्कुलर पाथ में लगा दिया है. Okay. 4 bolts are there arranged in circular path. This is bolt number 1, bolt number 2, bolt number 3, bolt number 4. Okay. They are arranged in circular path and we are applying a torque at the center. Okay. We are applying a torque at the center. How much? 200 Newton meter. Okay. अब यहां पे ध्यान दो क्या होने वाला है. Okay. In order to resist this torque, there will be only secondary force. Primary force आएगा ही नहीं because there is no force. There is only moment. और secondary force का direction हम कैसे देखते हैं मेरे भाई? For example, if you want to find secondary force in 1, then what I do beta? Draw a line and then perpendicular to this. So this will be secondary force in 1, this will be secondary force in 4, this will be secondary force in 3, this will be secondary force in 2. Okay. Now secondary force depends upon the distance from the center. All rivets from centroid are at equal distance. सारे रिवेट जो है सेंट्रॉइड से इक्वल डिस्टेंस पे हैं. So secondary force in all rivets will be same. Let me call this P, 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 P. How I will calculate this P? Beta, all these forces will apply how much torque? P into distance, P into distance, P into distance, P into distance. तो ये हो जाएगा 4 into P into what will be the distance? ये distance कितना है मेरे भाई? What will be this distance? ये distance कितना है? इस सर्कल का ये जो सर्कुलर पाथ है इसका डायमीटर 100 है. So this distance will be 50 mm, right? This circular path has diameter 100 mm. So this will be 50 mm. तो मेरे भाई ये हो जाएगा 4 into P into 50 equal to 200. तो P कितना आ रहा है मेरे भाई? 1 न्यूटन. 1 न्यूटन. P आ रहा है 1 न्यूटन. अच्छा सॉरी, ये mm में है तो इसको मैं ऐसा कन्वर्ट करूंगा. So this will be 1000 Newton. 1000 Newton, right? 1000 Newton. Very good. Very good, Kalpesh. 1000 Newton. Because this is in mm. This distance is in mm. So I will convert torque in Newton mm. So beta, now tau will be equal to what? Tau will be equal to what? Force upon area. And how much is the area? 25 mm square. So tau will be equal to what? 40 megapascal. Tau will be equal to what? 40 megapascal. Tau is 40 megapascal or what? Yes, Palak. Yes, Ayush. 1000 Newton. Yes, Prem. 1000 Newton. Tau 40 megapascal आ रहा है क्या? Tau 40 megapascal आ रहा है क्या? Yes. Tau is 40 megapascal. Yes, Ankita, Ayush. Yes, Kalpesh. Yes, Prem. Yes, Nitish. Tau is 40 megapascal. So do you understand how to solve this question? कॉन्सेप्ट अगर क्लियर है तो ऐसा कोई भी क्वेश्चन बन जाएगा. वेरी गुड स्वेक्षा, वेरी गुड जितेंद्र, जुबैर, दिव्यांशु, अंकिता, वेरी गुड. If your concepts are clear, beta, we have seen the entire derivation yesterday. So if your concepts are clear due to that, then beta, this question will also be very similar. Chalo. So beta, this was the last question of riveted joints. Bolted joint के question भी हमने इसी में कर लिए. We have solved the problems of bolted joints also because they are very similar. Okay. Now in bolted joints there are some things that you need to know. Beta, everything is not same. There are some things that are different. So let's understand bolted joints also. Okay, 2-3 points only you need to know about bolted joints. That is not seen in riveted joints. Okay, bolted joint के बारे में 2-3 चीजें बस जाननी है, उससे अलग कुछ नहीं जानना है. Okay, so let's see the bolted joint. So in case of bolted joint, what do we do? Just like riveted joint, we will drill holes in bolted joint also. हम ऐसे holes करेंगे. Then beta, we will insert a bolt. Okay, what is this? This is a bolt. This is a bolt. Okay. तो bolt insert करने के बाद one end will be closed, but the second end will not be closed. ये नहीं रहता है initially. Okay. So what we will do, from the second end we will insert a nut. What is this? This is a nut. Okay. This nut will travel on the bolt from these threads. Can you see? These are the threads. Okay. तो ये नट जो है थ्रेड्स के ऊपर ट्रेवल करता है. इट ट्रेवल्स ऑन द थ्रेड्स. ओके. एंड देन द सेकेंड एंड इज क्लोज्ड. सो दिस इज हाउ बोल्टेड जॉइंट्स आर मेड. ओके. समटाइम्स वी यूज वॉशर ऑल्सो. दिस इज नोन एज व्हाट? वॉशर. इट हैज नथिंग टू डू विद द जॉइंट. बेटा, व्हाट इज दिस डूइंग? इट हैज टू फंक्शंस मेनली. वॉशर के दो फंक्शन है. फर्स्ट इज इट डिस्ट्रीब्यूट्स द फोर्स ऑफ दिस ओवर अ लार्ज एरिया. ये जो नट है, जब मैं इसको टाइट करूंगा ना, आई विल टाइट दिस नट, देन दिस नट विल स्टार्ट टचिंग द प्लेट. इट विल अप्लाई फोर्स ऑन द प्लेट. सो द वॉशर डिस्ट्रीब्यूट्स दैट फोर्स ओवर अ लार्ज एरिया. जितना ज्यादा एरिया, स्ट्रेस उतना कम. ओके. एंड second point is, when you rotate this nut, then the surface of this nut makes scratches on the plate. When it will start touching the plate and you are rotating the nut, then the surface of the nut is not very smooth, it is rough. So it will make scratches on the plates, and due to that there will be stress concentration on plates. So in order to avoid that, we will put a washer. So if it makes scratch on washer and washer fails, we will have no issue, right? Thank you so much dost, thank you so much, thank you so much for your appreciation, thank you so much, it means a lot. Okay, so beta washer ke ye do kaam hai. Okay, if you want you can use washer, if you don't want you don't use washer. Okay, अब बेटा bolted joint को closely inspect करते हैं. Okay, so बेटा this is a bolted joint. Okay, this is the bolt, this is known as bolt head. जैसे rivet head होता है which is already closed, one end of the riveted joint is already closed due to the rivet head, वैसे ही bolt के केस में भी one end is already closed due to bolt head. Okay, एक end जो है bolt head की वजह से already closed है. The second end is not closed, the second end has threads on them. Okay, second end में आप देखोगे तो यहां से यहां तक there are threads, and this portion which is unthreaded is known as what? ये जो unthreaded portion है बेटा, this portion which is unthreaded is known as shank. This portion is known as shank. Okay, this is threaded portion, this is shank portion. Okay, then this is known as nut. Okay, thank you so much MS, thank you so much beta, thank you so much, it means a lot beta, means a lot, your appreciation means a lot to me. Okay, so beta, do you understand the major parts of the bolted joint? This is the bolt head which is already closed. Okay, one end is already closed due to this. Second end को close करने के लिए we put the nut on it. The nut travels on these threads. Some portion is unthreaded, okay, which is known as shank. अब बेटा look at this portion, threaded portion. Okay, look at this threaded portion. तो बेटा यहाँ पे अगर आप देखोगे, then there are 3 diameters of the bolt. This diameter is known as shank diameter. Okay, so beta unthreaded portion diameter, the diameter of the unthreaded portion is known as shank diameter. Now in the threaded portion there will be 2 diameters. Threaded portion को देखो बेटा, this is the threaded portion. Okay, so it will have 2 diameter. Okay, कैसे 2 diameter? Let's understand that. 2 diameter कैसे होंगे ये समझ लेते हैं. If you see this outer part, then beta if I consider this plane, ये वाला plane अगर मैं consider करूं, अगर मैं ये वाला plane consider करूं, then the diameter that I will get is known as nominal diameter or major diameter. This D naught is known as nominal diameter or major diameter. Okay, this maximum diameter of the threaded portion का maximum diameter. Okay, and if I see this, अगर मैं इस पोर्शन को कंसिडर करूं, इफ आई कंसिडर दिस बेटा, अगर मैं एक ऐसा प्लेन लूं, इफ आई कंसिडर दिस प्लेन, जैसे ये वाला प्लेन बेटा, आई विल गेट व्हाट? देन बेटा आई विल गेट व्हाट? आई विल गेट द मिनिमम डायमीटर. दिस डायमीटर इज नोन एज DC, which is what? Core diameter or minor diameter. Core diameter or minor diameter. Okay, core diameter or minor diameter. Okay, now beta this angle, ये वाला जो angle है, this angle is known as thread angle, and the distance between the two threads, this P is known as what? Pitch. ये जो दो threads के बीच का distance है, let's not write it here, let's write it here. ये जो दो थ्रेड्स के बीच का डिस्टेंस है, दिस डिस्टेंस इज नोन एज पिच. So I hope that this is clear. I hope that this is clear. The terminology of thread is clear. Okay, the terminology of thread is clear. Major diameter, core diameter, pitch, thread angle. Okay. Now beta, you might have seen this type of designation, right? Bolt का designation आपने ऐसा देखा होगा. In the questions also, you might have seen this type of designation, right? M12 into 1.25, something like this, right? So beta इसमें this 12 is what? This 12 is what? This 12 is D naught and this 1.2 is what? This is pitch. So D naught is 12 mm and pitch is 1.25 mm. Okay, D naught is 12 mm and pitch is 1.25 mm. Okay. So this is the bolt designation. M12 into 1.25 का मतलब diameter, nominal diameter is 12 mm and pitch is 1.25 mm. Okay. M stands for metric threads. There are different types of threads. So M stands for metric threads. Okay. तो मेरे भाई, I hope this is clear to everyone. अब यहाँ एक चीज ध्यान दो. Whenever we will design the bolted joint, then we will consider the minimum diameter. In order to find the stress, whenever you need to find the stress in the cross section, you will consider the minimum diameter. Out of D, D naught and DC, which one will be minimum? Out of D, D naught and DC, the minimum one usually the minimum one is DC. Okay. So मेरे भाई, if DC is the minimum diameter, we will use that. But यहाँ पे I am getting D naught. So beta, how I will calculate DC? So understand. First of all, you need to know that bolts are also made of standard sizes. Bolts, just like bearings, are manufactured in large quantity. Why? We have already discussed this in case of bearings. Bearings के case में हम already देख चुके हैं that in case of bearings, we manufacture bearings in very large quantity so that per unit cost will be very less. Just like that, bolts are also manufactured in lot. Bolts are also manufactured in large quantities so that per unit cost will be less. Now bolts have standard size M10, M12, M14, M16, M18. You will not get 12.65 mm bolt. No. Now beta, if you have design data book, you will find a table of metric threads bolts where beta, according to nominal diameter and pitch, you can find the core diameter. If you have the nominal diameter and pitch, then from that table you can find the core diameter. Okay. So if you don't know the core diameter here, you can find it out in the design data book. Okay. You need the nominal diameter and pitch in order to calculate core diameter. If you have these two, then you can find core diameter from the table. ठीक है? तो बेटा bolt के tables होते हैं because there are standard sizes. So bolts have these tables from which you can find DC. Designation में you will have D naught, but if you want to find DC, you can use that table. Okay. So I hope this is clear to everyone. Now beta, there are different types of threads. You don't have to get into this. Okay. Don't memorize this. Okay. इसको याद नहीं करना है. Don't memorize. बस समझ लो, देख लो थोड़ा सा. बाकी इसको याद करने की जरूरत नहीं है. Okay. You don't have to memorize all this. Okay. Just look at this. So there are different types of threads. Basically, I want you to understand three types of threads: square threads, acme threads, and buttress threads. Okay. तीनों में difference क्या है? In case of square threads, the thread angle is 90 degree. You can see the thread angle is 90 degree. यहाँ पे thread angle जो है ये कितना है? This angle is 90 degree. Okay. तो मेरे भाई यहाँ पे the shape of this thread is square. So that's why it is known as square thread. अब बेटा threaded joints जो हैं वो दो किस्म के एप्लीकेशन में काम आते हैं. Threaded joints are usually found in two application. One is power transmission device. Power transmission device like screw jack. Screw jack क्या करता है बेटा? Power transfer करता है ना. Screw jack transfers power. Okay. Then power screw, that also transfers power. Okay. So in those cases we see these threads. And the second application is holding any body like bench wise. बेंच वाइज के केस में हम क्या करते हैं? बॉडी को होल्ड करने का काम करते हैं. राइट. तो मेरे भाई Here there are two types of application. अब ये वाला जो थ्रेड है ये कौन से एप्लीकेशन में यूजफुल रहेगा? दिस थ्रेड विल बी यूजफुल इन द ट्रांसमिशन ऑफ पावर, लाइक पावर स्क्रू. पावर स्क्रू के केस में इट विल बी यूजफुल. ओके, नाउ इट इज यूज्ड इन मशीन टूल, स्पिंडल, स्क्रू जैक. एंड व्हाट इज द एडवांटेज? लेस वियर, बट इट इज डिफिकल्ट टू मैन्युफैक्चर एंड इट हैज लो स्ट्रेंथ. लेस वियर होता है, वियर कम होता है, बट इट इज डिफिकल्ट टू मैन्युफैक्चर एंड इट हैज लो स्ट्रेंथ. ड्यू टू दिस type of shape, it is difficult to manufacture. Okay, next type of thread is acme thread. Now what is the disadvantage of square thread? Difficult to manufacture and low strength. So beta, in acme threads we have overcome these disadvantage. acme thread बनाया ही इसलिए गया है ताकि square thread की कमियों को दूर किया जा सके. तो square thread की कमी क्या है? Difficult to manufacture and low strength. So in order to create it easily, manufacture it easily, and in order to increase strength, what we have done is, instead of square threads we have made it tapered. And what is the thread angle? The thread angle is 29 degree. Okay, thread angle is 29 degree. If you make it 30 degree, then it is known as metric thread. Okay, metric threads and acme threads are almost same, only this angle का difference is there. 29 degree की जगह वहां पे क्या रहता है? 30 degree. Okay, तो मेरे भाई अब इसमें difference क्या है? It is stronger than square threads. Why? बेटा यहां पे ध्यान दो. Here the base thickness is more. If it was a square thread, अगर ये एक square thread होता तो आपको base thickness बस इतनी मिलती, लेकिन ये extra thickness अब आपको मिल रही है due to this tapered shape. So बेटा that is the advantage, that it will have strong threads. Okay, this will be stronger than the square threads, but it will have a disadvantage, more wear. Due to this tapered shape there will be more wear. Okay, we will not get into the detail कि wear ज्यादा क्यों होता है. Okay, तो जो इसका एडवांटेज है वो इसका डिसएडवांटेज है, जो इसका डिसएडवांटेज है वो इसका एडवांटेज. Okay, both are very opposite of each other. Okay, and the third one is buttress thread, which is the combination of square and acme threads. कॉम्बिनेशन ऑफ स्क्वायर एंड एक्मे थ्रेड्स. अब इसमें हमने क्या किया है? एक साइड इज स्क्वायर एंड अदर साइड इज टेपर्ड. ओके, अब आप बोलोगे कि सर यही बनाना चाहिए फिर तो, बिकॉज इट हैज एडवांटेज ऑफ बोथ. दोनों का एडवांटेज है, वियर भी कम है और स्ट्रेंथ भी ज्यादा है. बट डिसएडवांटेज क्या है? दीज टू थ्रेड्स कैन ट्रांसफर पावर इन बोथ साइड्स. These two threads can transfer power in both direction, but this thread can transfer power only in one direction. दूसरी direction में power transfer नहीं हो पाता. Okay, so this is used only if you want to transfer power in one direction. Okay, so this is combination of these two. तो बस इतना ध्यान में रखना, और कुछ ध्यान में रखने की जरूरत नहीं है. Okay, you don't have to memorize all these values and all. Okay, just need to know about this. Okay, next topic is very important, which is bolt preload. Now you might have seen this in strength of material also. Strength of material में भी पढ़ा होगा bolt preload. What is bolt preload? Understand, when we start inserting the nut initially, मान लो आपके पास दो प्लेट्स हैं. let's say you have two plates. let's say you have two plates like this. Okay, and you are connecting them by means of a bolt. Okay, you are connecting them by means of a bolt. Let's say this is my bolt. Okay, so one end is closed but the other end is not closed. दूसरा end जो है वो तो closed नहीं है. दूसरे एंड पे there are threads like this. So what I will do? I will start inserting a nut. तो मैं एक नट ले लेता हूं. I will pick a nut and I will start putting this nut on the bolt. Now initially there will be gap between this thread and this plate and the nut. So I can insert this nut freely. Right now when I will try to rotate this nut, it will rotate freely. But बेटा घुमाते घुमाते क्या होगा? Understand, हे भगवान, इसको कॉपी कैसे करते हैं यार? ओके चलो छोड़ो, घुमाते घुमाते क्या होगा, when I will start rotating it, there will be a point when this nut will start touching the plate, right? घुमाते घुमाते I will reach to a point when this nut will start touching the plate. Now after this point, if I am rotating the nut, after this point if I am rotating the nut, अगर मैं इस point के बाद भी rotate करूंगा, then is there any gap between the nut and plate? No, there is no gap between the nut and plate. Okay, so after this point if I again rotate this, then this nut will start applying force on the plates. जो नट है वो प्लेट्स के ऊपर फोर्स लगाना चालू कर देगा, एंड बदले में इन रिटर्न प्लेट विल अप्लाई फोर्स ऑन द नट. Why this force is developed? Because if I rotate this nut, there is no gap for the nut to move. The nut wants to move, but there is no gap. So if I rotate the nut further, then it will start applying the force on the plate, and the plate will apply opposite force on the nut. This force is known as bolt preload. This force is known as bolt preload. Now you might be thinking, sir, if I am getting a load, then why doing this? Let's not rotate the nut further. Let's just keep the nut like this. Let's just stop here. But if you stop here, what is going to happen, beta? Will your joint be tight? क्या आपका joint tight रहेगा? आप नट को घुमाओ, जब तक freely घूम रहा है तब तक घुमाओ, जैसे ही ये प्लेट को टच करेगा छोड़ दो. Okay, you start rotating the nut, initially it will be free because there will be gap. Now when it touches the surface of the plate, you don't rotate it further, you keep it like that. What will happen? If you stop at that point, the joint will be loose. So if I apply even a slightest force, this nut will come out, and I don't want that. I want my plates to be tightly connected to each other so that they don't become loose. So in order to tightly connect them together, I need to rotate it further, and when I rotate it further, there will be a force created. Okay, this further tightening will apply a compressive force on plate and a tensile force on bolt. This is known as bolt preload, which is denoted by PI. PI is what? Bolt preload or initial load. Okay, bolt preload or initial load. Now beta, this bolt preload is very important. Bolt preload बहुत ज़्यादा important है. Why it is very important? Understand. Beta, if you have bolt preload, then beta the plates will be clamped together. अगर आपके पास bolt preload है तो plates एक दूसरे से tightly connected हैं. If you have bolt preload, the plates are tightly connected together. Otherwise they will become loose. So bolt preload is important beta. Bolt preload के बगैर काम नहीं चलेगा. Bolt preload जरूरी है. Okay. So I hope you understand this point. Bolt preload is important. Okay. So beta, there are two advantages of bolt preload. Two very important advantages of bolt preload. क्या है दो बहुत इंपॉर्टेंट एडवांटेज? वन इज इट होल्ड्स द प्लेट्स टुगेदर. It holds the plates together by applying a compressive force. एक तो जो compressive force है, that is holding the plates together. And second point, under fluctuating load, it increases the fatigue life of bolts. Now beta, we will not discuss this point in detail. Okay, we will not discuss this point in detail because it will be a waste of time, but you need to understand that under fluctuating load, if there is fluctuating load, then beta, if you have bolt preload, then the fatigue life of bolt will increase. If you have bolt preload, then the fatigue life will increase. If you have fatigue load, then the bolt preload will increase. मेरे भाई कल्पेश, अगर ये नहीं होता, अगर ये टॉपिक पढ़ना जरूरी नहीं होता तो मैं क्यों पढ़ा रहा होता? मेरे पास इतना सारा फालतू टाइम तो है नहीं कि मैं जबरदस्ती के टॉपिक्स पढ़ाऊंगा. आप ऑलरेडी देख रहे हो कि मैं सिर्फ वही टॉपिक्स पढ़ा रहा हूं जो गेट के सिलेबस में है, जिससे क्वेश्चंस आते हैं. फिर भी आप पूछ रहे हो. अगर आपके पास इतना टाइम नहीं है तो आप, कोई दिक्कत नहीं है, लेक्चर मत देखो, लेकिन इस टाइप के सवाल पूछने का कोई पॉइंट नहीं है ना कि सर ये टॉपिक है कि नहीं गेट के सिलेबस में, या फिर आप अपने घंटे बढ़ाने के लिए, टाइम पास करने के लिए यहाँ आ रहे हो. मेरे पास भाई और भी बहुत सारे काम है, तो टाइम पास करने के लिए कोई भी टॉपिक में क्यों पढ़ाऊंगा? अगर मैं कोई टॉपिक पढ़ा रहा हूं तो इसका मतलब वो सिलेबस में है. ठीक है, चलो. So beta, these are the two very important advantages of bolt preload. Okay, you need to remember that. ये वाला तो मैंने समझा दिया. ये वाले में अगर घुसेंगे तो टाइम वेस्ट होगा, तो इसीलिए मैं ये वाला पॉइंट ज्यादा डिस्कस नहीं करूंगा डिटेल में. Okay, so you understand this bolt preload? Okay, so this bolt preload is very important load, and there will be stresses developed in the bolt and the plates due to this bolt preload. Okay, now एक तो bolt preload की वजह से स्ट्रेस आता ही है. Another stress is developed due to external load. अब external load की वजह से भी स्ट्रेस आता है. External load किस तरीके से लग सकता है? There are two cases of external load. The load can be tensile like this or it can be like this. ठीक है, लोड जो है वो टेंसाइल भी हो सकता है और इस तरीके से शियर भी हो सकता है. अब बेटा एक केस में टेंसाइल लोड लग रहा है तो इसमें टेंसाइल स्ट्रेस डेवलप होगा. सिग्मा टी विल बी इक्वल टू व्हाट? P upon pi by 4 dc square. Understand beta, I am using a core diameter because this is the minimum diameter. Okay, I am using the core diameter because this is the minimum diameter. तो यहाँ टेंसाइल स्ट्रेस डेवलप होगा, और अगर लोड ऐसा लग रहा है देन शियर स्ट्रेस डेवलप होगा. तो दिस विल बी P upon pi by 4 dc square. Formula will remain same but the stress will be different. In this case there will be a shear stress. ठीक है, इस केस में shear stress डेवलप होगा, राइट? So beta, this is tensile loading, this is shear loading. Okay, so beta these two types of external load can be there. Okay, so bolt preload से stress आएगा, external load से भी stress आएगा. Okay, bolt preload से stress आएगा, external load से भी stress आएगा. चलो, so beta is this clear? Is this clear? Now beta, eccentrically loaded bolted joint. अब एसेंट्रिकली लोडेड रिवेटेड जॉइंट के कल हमने जो दो केसेस देखे थे, वी सॉ टू केसेस ऑफ एसेंट्रिकली लोडेड रिवेटेड जॉइंट. द सेम केस इज आल्सो देयर अंडर बोल्टेड जॉइंट. बोल्टेड जॉइंट में भी यू गेट द सेम केसेस. केस नंबर 1 इन प्लेन लोडिंग, केस नंबर 2 आउट ऑफ प्लेन लोडिंग. ओके, यू कैन सी दैट राइट नाउ इंस्टेड ऑफ रिवेट्स आई हैव बोल्ट्स. रिवेट की जगह हमारे पास क्या है मेरे भाई? रिवेट्स की जगह हमारे पास बोल्ट है. ओके, कल्पेश ने डिसलाइक का बटन भी दबा दिया है क्या? कल्पेश को बहुत बुरी लग गई मेरी बात. खैर कोई बात नहीं मेरे भाई, बट मेरा बोलना ये जरूरी है ताकि मुझसे ज्यादा क्वेश्चंस जो हैं इस बारे में कोई ना पूछे कि ये वाला टॉपिक क्यों पढ़ा रहे हो, वो वाला टॉपिक क्यों पढ़ा रहे हो. आप लोगों को ऑलरेडी मैं इतने बार समझा चुका हूं कि अगर मैं यहाँ आ रहा हूँ, इतना एफर्ट लगा रहा हूँ, तो ऐसे ही टॉपिक्स ना लेके आऊंगा जो आप लोगों के सिलेबस में है. तो आप लोग सिलेबस की चिंता क्यों करते हो? आप लोग सिलेबस की चिंता क्यों करते हो? यहाँ पे जितने भी टीचर्स आ रहे हैं वो सालों से गेट के लिए पढ़ा रहे हैं, ईएस के लिए पढ़ा रहे हैं. तो हम लोगों को पता है ऑलरेडी कि कौन से टॉपिक सिलेबस में है, कौन से टॉपिक सिलेबस में नहीं है. तो आप लोगों को इतना चिंता करने की जरूरत नहीं है कि सर एडिशनल टॉपिक कब होंगे. एडिशनल टॉपिक क्या है मेरे भाई? अगर कोई टॉपिक ऐसा होगा जो नया ऐड हुआ होगा तो उसकी क्लास भी मैंने ली होगी ना. शियर सेंटर का टॉपिक जो है वो एडिशनल ऐड हुआ था सॉम में, तो शियर सेंटर मैंने पढ़ाया ना. इंजीनियरिंग मैकेनिक्स में एडिशनल टॉपिक ऐड हुआ था तो उसकी भी क्लासेस मैंने ली ना. तो ऐसा तो है नहीं कि कोई टॉपिक होगा सिलेबस में और वो मैं पढ़ाऊंगा नहीं. ठीक है, तो आप लोगों को इतना चिंता करने की, इतना बुरा मानने की जरूरत नहीं है. आप लोगों को बस यहाँ पे लेक्चर्स अटेंड करने हैं, आप लोगों को बस अपना टाइम देना है और एफर्ट मारना है. बाकी की चिंता हम लोगों पे छोड़ दीजिए. आप लोगों को अगर हम लोग यहाँ पढ़ा रहे हैं तो इसका मतलब यही है कि हम अपनी रिसर्च करके आए हैं कि कौन से टॉपिक से क्वेश्चन आते हैं, क्या सिलेबस में है क्या नहीं है. वेल डिफाइंड सिलेबस नहीं है, हमें पता है. सिलेबस में एकदम ऊपर से लिख दिया बोल्टेड जॉइंट, तो बोल्टेड जॉइंट में क्या पढ़ना है क्या नहीं पढ़ना है वो चीजें मेंशन नहीं है. रिवेटेड जॉइंट में क्या पढ़ना है क्या नहीं पढ़ना है मेंशन नहीं है. वेल्डेड जॉइंट में क्या पढ़ना है क्या नहीं पढ़ना है मेंशन नहीं है. लेकिन उसके लिए हम लोग है ना, हम लोगों ने सालों से रिसर्च की है, सारे पीवाईक्यूज हमें रटे हुए हैं, कौन से टॉपिक से कितने क्वेश्चंस आए हैं, किस साल कौन से टॉपिक से क्वेश्चन आया है, किससे नहीं आए हैं, ये सारी चीजें हमें ध्यान में है। क्यों ध्यान में है? क्योंकि हम फालतू नुकसान नहीं करना चाहते ना। देखो बेटा, दिक्कत यह है कॉम्पिटेटिव एग्जाम में सिलेबस बहुत ज्यादा होता है, सिलेबस बहुत ज्यादा होता है, तो इसीलिए हम लोगों को सिलेबस में जो मेंशन है वही पढ़ना है, जिससे सवाल आते हैं वही पढ़ना है, फालतू की चीजें नहीं पढ़नी है। तो इसलिए मैं फालतू के टॉपिक्स पढ़ाता ही नहीं हूं। मशीन डिजाइन अगर मैं ऐसे पढ़ाने बैठूंगा बेटा तो 100 घंटे भी कम पड़ेंगे। मशीन डिजाइन में बहुत सारी ऐसी चीजें हैं जो हम लोग नहीं पढ़ सकते, क्योंकि वो सिलेबस में एक तो है नहीं और दूसरा इतना टाइम नहीं है। ठीक है, अब मेरे पास तो बहुत टाइम है, लेकिन आप लोगों के पास टाइम नहीं है, इसीलिए मैं सिर्फ ऐसे टॉपिक्स प्रिसाइज तरीके से पढ़ाता हूं जो सिलेबस में है, जिससे क्वेश्चन आते हैं, जिससे क्वेश्चन कभी आए ही नहीं है और ना आने की कोई संभावना है, वो टॉपिक्स में यहाँ कवर ही नहीं करता हूं। ठीक है, बहुत सारे बच्चे पूछते रहते सर आप ये टॉपिक कब पढ़ाओगे, सर आप वो टॉपिक कब पढ़ाओगे, तो वो टॉपिक्स में इसीलिए नहीं पढ़ाता हूं मेरे भाई कि वो पढ़ा के कोई फायदा नहीं है। ऐसा थोड़ी है कि मुझे आता नहीं है। मैं 6 सालों से अगर मशीन डिजाइन पढ़ा रहा हूं तो ऐसा तो होगा नहीं ना कि कोई टॉपिक मुझे आ नहीं रहा है और लेकिन मैं 6 साल से पढ़ ही नहीं रहा हूं। अगर मुझे कोई टॉपिक नहीं आता तो इन 6 सालों में मैं कभी तो पढ़ लेता, है कि नहीं? अगर मुझे कोई टॉपिक नहीं आता तो मैं 6 साल में कभी तो उठा के पढ़ लेता। अगर स्टूडेंट्स पढ़ सकते हैं वो टॉपिक तो टीचर तो पढ़ ही सकता है, तो मैं पढ़ के तो पढ़ा देता। लेकिन अगर मैं नहीं पढ़ रहा हूं, नहीं पढ़ा रहा हूं, तो इसका मतलब यही है मेरे भाई कि वो टॉपिक इंपॉर्टेंट नहीं है, वो टॉपिक अपने को पढ़ना नहीं है, उसमें टाइम वेस्ट करके फायदा नहीं है। तो बहुत रिसर्च करके और बहुत ज्यादा मगजमारी करके ये सारे टॉपिक्स चुन चुन के आपके सामने लेके आते हैं, तो आप बिंदास होके पढ़ो। आपको टेंशन लेने की जरूरत नहीं है कि सर ये टॉपिक पढ़ना है कि छोड़ना है, ये करना है कि नहीं करना है, आप ये कब कराओगे, ये कब नहीं कराओगे। आपको मैंने क्या बोला, अभी बस 2 चैप्टर और बचे, गियर बचा है और स्प्रिंग बचा है, उसके अलावा आपको कुछ नहीं पढ़ना है। गियर और स्प्रिंग ये 2 चैप्टर और हैं बोल्टेड जॉइंट के बाद, उसके अलावा अपने को कुछ देखने की जरूरत ही नहीं है। ओके, थैंक यू सो मच गाइस, थैंक यू सो मच, थैंक यू सो मच, थैंक यू सो मच, थैंक यू सो मच, लव यू ऑल, लव यू ऑल। ओके चलो, सो बेटा केस 1 एंड केस 2 ऑफ eccentric loading in bolted joint is very similar to riveted joint, so you don't have to understand the process again. Instead of rivets now we have bolts. That is the only difference. सिर्फ यही difference है कि रिवेट हटा के बोल्ट लगा दिया गया है। ठीक है, बाकी सारी चीजें सेम है, everything else is similar. Okay, so beta I will not teach the 2 cases again. Okay, but beta there is one more topic which is very important, and that is stiffness analysis of bolted joint. Okay, now till now there has never been a question from this, but beta from theory you might get a question. Okay, iski theory se question aa chuka hai, you have got theory question from this, you have got theory question from this. Okay, thank you so much, thank you so much, thank you so much. Okay, तो आपको थ्योरी के ऊपर क्वेश्चन आए हैं, न्यूमेरिकल नहीं आता बट इसकी थ्योरी से आता है। ओके, सो अंडरस्टैंड व्हाट डू आई मीन बाय स्टिफनेस एनालिसिस। लेट्स से वी हैव 2 प्लेट्स. ओके, दिस इज प्लेट नंबर 1, this is plate number 2. Okay, they are kept like this and they are connected by a bolt, and I am applying a force like this P. Okay, now when I apply a force P, then what will happen is this bolt and this plate, this region of plate, itna region plate ka, this bolt and this region of plate will resist this force together, will resist this force together. This bolt and this plate will resist the force together, means some force out of this force P, some force will be resisted by bolt and some force will resisted by plate. Let's say out of P, TB is the external force resisted by bolt, and PC is external force resisted by plate. अब इसको मैं PC क्यों बोल रहा हूं? Why I am using this letter C? C is used for clamped part. This much part is clamped, है ना, इतना part जो है वो clamped है, this much part is clamped, so C stands for that clamped part. Okay, so बेटा understand, I am applying a total force P, but this total force will not go into bolt, this total force will not go into plates. Some force will be resisted by bolt, some force will be resisted by plate. Okay, How much force? PB and PC. So can I say PB plus PC is equal to P? Yes, I can say that. Okay. Now, how much force will go into bolt and how much force will go into plate? That will depend upon the stiffness of bolt and plate. KB is stiffness of bolt, and KC is stiffness of plate. So understand beta, KB is the stiffness of the bolt and KC is the stiffness of the plate, and the value of KB and KC will decide. The value of KB and KC will decide how much force will be resisted by bolt, how much force will be resisted by plate. Means the value of PB and PC will depend upon KB and KC. How they will depend upon KB and KC, that we have to see in the stiffness analysis. I hope this is understood. क्या पढ़ना है exactly इस topic में, stiffness analysis में? If I am applying a force P, how much force will go into bolt, how much force will go into plate? Okay. Now let's say delta is the deflection. Delta is the deflection in bolt and plate, and it will be equal beta. It will be equal. Why? Beta, bolt and plate are connected in connected in parallel. Bolt और plate कैसे connected है? Parallel में connected है. Okay. So beta, if I apply a force P, then beta, the deformation in both will be same. The deformation on both will be same. Force will be different. Series connection में force is same, deformation is different. Parallel connection में deformation is same, force is different. So force दोनों में different है, deflection दोनों में same है. Okay. So that is parallel connection. अब बेटा इसमें KC तो आपको डायरेक्टली दिया रहेगा, बट KB कभी कभी डायरेक्टली भी दिया रहता है, कभी कभी नहीं भी दिया रहता है. Some cases they will give you direct value of KB. In some cases you have to calculate. For example, there is a question in GATE in which you need to calculate the value of KB only. KB के calculation पे question आ चुका है. Okay. So let's understand how to calculate KB. So let's say I have given you the bolt. This bolt has threaded portion and unthreaded portion. Okay. Now what will be the stiffness? First of all, I am applying axial load. So beta, there will be axial stiffness. Understand? Under axial load, which stiffness I am talking about? If I am saying stiffness under axial load, it will be axial stiffness, and the formula of axial stiffness will be AE by L. Okay. Now if you have constant area, then you can calculate directly stiffness AE by L. But beta, is the area constant? क्या area constant है? नहीं है. The problem is the area of unthreaded portion is different. The area of threaded portion is different. Okay. Let's say area A1, area A2, length L1, length L2. Okay. E will be same. Now what I will do? Can I assume that these are just like two springs? These bodies are just like two springs which are connected in series, and the stiffness of these spring is K1 and K2. So if the stiffness of spring is K1 and K2 and they are connected together in series, then how do we calculate the effective stiffness? Means if I combine both of them, how will I calculate the total stiffness? 1 by K will be equals to 1 by K1 plus 1 by K2. What will be K1 beta? A1E by L1, and what will be K2 beta? A2E by L2. So do you understand how the stiffness of the bolt is calculated? I hope it is understood by every student. If you do understand this beta, hit the like button, and if you understand, share it with your friends and let them know that this is how we calculate the stiffness of the bolt. Okay. There is a question in GATE based on this concept. इस concept के ऊपर GATE में question आ चुका है. Okay. They will give you area of unthreaded portion and threaded portion, length of unthreaded portion and threaded portion, and Young's modulus, and they will ask you to calculate stiffness of the bolt. So this is how we calculate the stiffness. If the area was constant, I would have calculated the stiffness directly using this equation. सीधे मिल जाता AE by L. बट एरिया कांस्टेंट नहीं है, इसीलिए मैं ऐसा नहीं कर सकता, ठीक है। तो मैं क्या करूंगा बेटा, आई विल अज्यूम दैट दीज आर टू डिफरेंट बॉडीज कनेक्टेड टुगेदर इन सीरीज, एंड सीरीज में इफेक्टिव स्टिफनेस का फॉर्मूला इज दिस 1/k equals to 1/k1 plus 1/k2. Now k1 k2 can be individually calculated by a1 e by l1 a2 e by l2. Okay, very simple. Okay, so let's say you have calculated kb, मान लो kb निकल गया. Okay, now बेटा pb is the force in the bolt. So what will be the relation between force, stiffness and deflection? Can I write this? pb equals to kb into delta, pc equals to kc into delta. Can I write this? Yes, I can write this. Now I know that p will be equals to pb plus pc, right? P will be equals to pb plus pc. Now pb is what? kb into delta. pc is what? kc into delta. So from here, can I say delta equals to p upon kb plus kc? Can I say that? Can I say that? Delta equals to p upon kb plus kc. Now put the value of delta into this equation again. अब इस इक्वेशन में डेल्टा की वैल्यू रख दो मेरे भाई. तो इफ आई पुट द वैल्यू ऑफ डेल्टा हियर, देन pb will be equal to what बेटा? kb into p upon kb plus kc. Can I write it like this? pb equals to kb upon kb plus kc into p. Can I write it? Can I write this? Now in this equation, this kb upon kb plus kc, this value will decide how much force out of p will go into pb. How much force out of p will go into the bolt. इतने फोर्स में से बोल्ट में कितना फोर्स जाएगा वो कौन डिसाइड करेगा? दैट विल बी डिसाइडेड बाय दिस पैरामीटर kb upon kb plus kc, and this kb upon kb plus kc is known as stiffness constant. Okay, stiffness constant. Okay, stiffness constant of spring. This is known as stiffness constant of spring. Okay, so can I say pb equals to c into p, where c is stiffness constant. Okay, now beta pc is p minus pb, and this is cp minus p. Sorry, उल्टा लिख दिया. This is p minus cp. So what will be pc beta? Can I write it 1 minus c into p? Yes. So beta pb will be c into p and pc will be 1 minus c into p, right? pb will be c into p and pc will be 1 minus c into p. ठीक है, thank you so much, Ashwin. So beta, if I know the value of c, then I can tell you that this much force will go into bolt and this much force will go into plate. Okay, so that will be decided by this value c, which is known as stiffness constant. Okay, तो stiffness constant decide करता है कि एक bolted joint में कितना force bolt में जाए और कितना plate में. Now बेटा, in different applications the value of c is different according to your need. Sometimes you need more load in bolt, sometimes you need more load in plate. आपके नीड के हिसाब से, एप्लीकेशन के हिसाब से, किसी केस में आप चाहोगे कि बोल्ट ज्यादा फोर्स उठाए, कोई केस में आप चाहोगे कि प्लेट ज्यादा फोर्स उठाए. ओके, सो हाउ मच फोर्स बोल्ट विल कैरी, हाउ मच फोर्स प्लेट विल कैरी, दैट वी विल डिसाइड बेस्ड ऑन द टाइप ऑफ एप्लीकेशन. ओके, इन डिफरेंट एप्लीकेशन आवर नीड इज डिफरेंट. ओके, वी विल नॉट गेट इनटू द डिटेल्स. हम लोग डिटेल में नहीं जाएंगे कि कौन से केस में बोल्ट में फोर्स ज्यादा जाना चाहिए, किसमें प्लेट में फोर्स ज्यादा जाना चाहिए, क्या वैल्यू होगी, यूजुअली क्या वैल्यू होती, विल नॉट गेट इनटू दैट. ओके, यू जस्ट नीड टू अंडरस्टैंड दिस स्टिफनेस कांस्टेंट, बिकॉज बेटा थ्योरी में दे माइट आस्क यू दिस क्वेश्चन, व्हाट इज स्टिफनेस कांस्टेंट. ओके, सो न्यूमेरिकल यू विल नेवर गेट, but theory question you might get. So do you understand? Do you have an idea now? Stiffness analysis of bolted joint. Very good. So this is one particular topic which I wanted you to understand, and another, the most important topic out of which you will get questions, maximum times you will get questions in theory, is bolt of uniform strength. Okay, theory question आने की सबसे ज़्यादा संभावना इसी topic से है. Okay, now beta, what is bolt of uniform strength? What is uniform strength? Understand. Uniform strength means in every cross section the stress is equal, just like beam of uniform strength. I told you beam of uniform strength in SOM. In every cross section stress is same. So when we apply force in bolted joint, what happens is the stress in unthreaded portion is less and the stress is threaded portion is more. Okay, this is what, let's say here the sigma is 100 megapascal and here the sigma is 150 megapascal. Okay, so this is not bolt of uniform strength. What will be a bolt of uniform strength? If the stress here and here are equal. Now beta, will you reduce this stress? You can't reduce this stress, but can you increase this stress? Yes, I can increase this stress. I can increase this stress up to what level? I can increase this stress up to 150. Why I can increase this up to 150? Because beta, I have already designed this bolt to sustain 150 megapascal, right? When you are designing the bolt, you have already seen that the stress must be less than or equal to this, matlab it can resist this much amount of stress. Okay, so beta, I can increase this up to 150. So if I make this 150, then the stress in entire bolt will become same. That will be my bolt of uniform strength. Now you might be thinking, why we purposely increase the stress in this area? Because our intention, our objective is always to reduce the stress. So why we are intentionally increasing the stress in this area? So understand the logic behind that. Okay, first of all, in order to understand the relation between this, in order to understand the significance of this, you need to understand an important parameter known as resilience, which I have taught in strength of material. What is resilience? Resilience is strain energy stored per unit volume, and it is given by sigma square by 2e, modulus of resilience. Okay, this is modulus of resilience, sigma square by 2e. Okay, so this is a property of the object which determines how much energy this body can store without permanent deformation. कोई बॉडी कितना एनर्जी सह सकता है, how much energy it can absorb, it can sustain without permanent deformation, that is resilience, and it is strain energy per unit volume sigma square by 2e. Now why do we need to store the energy? Understand, this property comes into picture under vibration, under shock, under impact load. Impact load means load striking with some velocity, like punching. If you are punching a body, then it is load striking with some velocity. If you are hammering a body, you are giving load with some velocity. So in that case, the strength of the body depends upon resilience. If the resilience is more, the body will be able to sustain more impact load. If I am applying impact load on a body, how much impact load it can sustain, that will depend upon its resilience, its ability to absorb energy. जितना energy वो सह लेगा, उतना load मैं उसके ऊपर लगा सकता हूँ. Okay, the amount of energy it can sustain will decide how much load I can apply. So do you understand what is resilience? How much energy it can absorb, and when I will calculate resilience? When I am applying impact load. Okay, now what is the relation between this and this? Understand. Let's say I am using a bolted joint under vibration or impact load. So I want my bolt to be resilient. I want my bolt to absorb more and more energy, right? Now the energy absorbed will depend upon this equation, sigma square by 2e. Now I can't do anything about E. I can't do anything about E. Forget about E. Look at sigma. In case of normal bolt, regular bolt, the sigma in this portion is more, the sigma in this portion is less. Means this much portion is absorbing more energy, this much portion is absorbing less energy. Means this is not absorbing maximum amount of energy. When it will absorb maximum amount of energy? If I make the sigma of this part equal to this part, then this part will also absorb maximum energy. Then in that case, I will get maximum resilience. Do you understand my point, what I am trying to say? मैं क्या समझाना चाह रहा हूं, समझ रहे हो? मेरी बोल्ट को मुझे रेजिलियंट बनाना है, ज्यादा से ज्यादा एनर्जी स्टोर कर सके. उसके लिए मैं ई को तो कुछ नहीं कर सकता, सिग्मा को कर सकता हूं. इस पार्ट के सिग्मा को कुछ नहीं कर सकता, इसको बढ़ाओगे फेल हो जाएगा, लेकिन इसको बढ़ा सकते हो. कहां तक बढ़ा सकते हो? 150 तक बढ़ा सकते हो, क्योंकि 150 सहने के लायक बना दिया है आपने. ये 150 झेल सकता है, इतना पार्ट भी 150 झेल सकता है, लेकिन आप लगा रहे हो इसके ऊपर सिर्फ 100. मतलब आप इसको 150 तक बढ़ा सकते हो. बढ़ा दो अगर इस पार्ट के स्ट्रेस को भी 150, तो ये क्या बन जाएगा? दिस बोल्ट विल बिकम bolt of uniform strength, and in that case it will have maximum resilience. So bolt of uniform strength has maximum resilience. Do you understand why do we need to increase the stress in this part? So that this part will also absorb maximum energy. In that case, this bolt will become bolt of uniform strength. So I hope this point is understood by every student of mine. What is bolt of uniform strength? ये क्लियर हुआ? बोल्ट ऑफ यूनिफॉर्म स्ट्रेंथ क्या है और क्यों चाहिए, ये क्लियर है. अब बोल्ट ऑफ यूनिफॉर्म स्ट्रेंथ बनाएंगे कैसे? हाउ वी विल मेक इट अ बोल्ट ऑफ यूनिफॉर्म स्ट्रेंथ? अंडरस्टैंड, द फोर्स इन बोथ एरिया इज सेम बट स्ट्रेस इज डिफरेंट. व्हाई स्ट्रेस इज डिफरेंट? बिकॉज द एरिया इन बोथ रीजन्स इज डिफरेंट. In this region area is less, in this region area is more. So if I want the stress in both cases same, then the area in both region must be same. Load is same. If the area is also same, the stress will become same. So beta, in order to make the bolt of uniform strength, I need to make the area of shank equal to area of thread. Which area of thread? Minimum area of thread. Calculating stress, for calculating stress we use minimum area na. So area of shank must become equal to minimum area of thread. अब मैं area of shank को reduce करना चाहता हूं. I want to reduce my area of shank up to minimum area of thread. So I have two options. First is I will reduce the diameter of shank to diameter of thread, minimum diameter of thread. So beta, now this area will also be pi by 4 dc square, this area will also be pi by 4 dc square. So I have got bolt of uniform strength. This is one option. Okay, this is one option. Reduce the shank diameter up to core diameter. Okay, what is the second option? Drill a hole inside the shank. Drill a hole in the shank part. So if I drill a hole in the shank part, then the cross sectional area will be reduced. Now beta, how much diameter of hole I have to drill? So area of shank has to become minimum area of thread. Now area of shank after drilling a hole will become this much, and minimum area of thread is how much? Pi by 4 dc square. So from this relation, the diameter, required diameter of hole will be this. So if you drill a hole of this diameter, then area of shank will become equal to area of thread, and it will become bolt of uniform strength. I hope this is clear to everyone. I hope this is clear to everyone. Beta, you get a lot of theory question from bolt of uniform strength. Bolt of uniform strength से बतेरे question आए हैं आज तक. GATE में, ES में, PSUs में, a lot of question. Okay, so understand bolt of uniform strength very clearly. What is bolt of uniform strength, why it is needed, and how it is made. Okay, तो ये चीज I hope clear है. So beta, this is the end of bolted joint. You don't need to understand anything else in bolted joint. Whatever we have seen in bolted joint, that is enough. Okay, so we have seen what is a bolt. Okay, we have seen different parameters of bolt. We have seen types of threads. We have seen bolt preload. We have seen external load. We have seen eccentric loading case. We have seen stiffness analysis. We have seen the bolt of uniform strength. This much you need to know. Okay. Now before leaving, a very important announcement I need to make. Tomorrow we have 5-hour marathon class at 9 a.m. Okay, at 9 a.m. Where? On YouTube channel. So beta, I want all of my students to be there at 9 a.m. in order to revise this topic with me. Dynamics of particle and rigid body. Engineering mechanics ka last part. Okay, dynamics of particle and rigid body. After this, our engineering mechanics revision will be over. From next month, I will start revision of strength of material. Only important topics like shear force and bending moment diagram, thermal stress, deflection of beams, important topic revision will be there. Okay. So beta, this will be the revision, complete revision of dynamics. Tomorrow 9 a.m. Kal subah 9 baje 5-hour marathon class. Kal subah 9 baje 5-hour marathon class. Thank you so much Divyanshu. Okay. Then beta, after tomorrow, Sunday, after Sunday, on Monday, Tuesday and Wednesday, on special class, not on YouTube. This is on YouTube. This is on special class on Unacademy. We have live full syllabus test of machine design, SOM and EM. When? 4 p.m. Sham ko 4 baje. We have 2 to 4 p.m. theory of machine class. Theory of machine class is 2 p.m. to 4 p.m. Then from 4 p.m. to 5 p.m., 1 hour, we will have test on machine design, strength of material, engineering mechanics, and it will be a test of MSQ, MCQ, NA type question. इसमें MSQ question रहेंगे, MCQ question रहेंगे, NA question रहेंगे, and the entire test is designed by me. I will share the link. I will share the link in 5 minutes in my Telegram channel. मैं अपने Telegram channel में share करने वाला हूँ link. So beta, please follow my Telegram channel in order to get the link of all these classes. Okay, open your Telegram app and search Apuroop 10. You will join this Telegram channel. I will share the link of these 3 classes. इन तीनों classes की link मैं share करने वाला हूँ at 9:30 p.m. 9:30 p.m. को मैं share करूंगा. Okay, तो Sunday का plan, Monday, Tuesday, Wednesday का plan. Now Thursday, on the last day of this year, 31st of December, Thursday at 9 a.m. we have again 8 hours marathon class on complete revision of machine design. I told you there are only 2 chapters left, gear and springs. So beta, on Wednesday evening the springs will end, complete syllabus of machine design will end. On 31st of December 9 a.m. we will have 8-hour marathon class, complete revision of machine design. Where? On YouTube. तो मेरे भाई 31st of December तक का प्लान मैंने आपको बता दिया. ओके, टुमारो 5-hour marathon class, then Sunday को 5-hour marathon class, then Monday, Tuesday, Wednesday test, and then Thursday 8-hour marathon class on YouTube. Okay, marathon classes will be on YouTube, test will be on special class. The links of all these I will share in my Telegram channel right now. 9:30 p.m. को I will share. So please join. Okay, please click on those links and click on notify me. स्पेशल क्लास की जो लिंक मैं भेजूंगा, उस पे क्लिक करना, ओपन करना एंड प्रेस द नोटिफाई मी बटन सो दैट यू विल गेट द नोटिफिकेशन बिफोर 15 मिनट्स व्हेन आई विल बी लाइव. ओके, तो आप मिस ना करें, इसके लिए यू हैव टू प्रेस द नोटिफाई मी बटन. ओके, हिट द लाइक बटन एंड प्लीज शेयर द लिंक्स. whatever link I will share with you, you have to forward it in your groups also, because beta we need maximum participation in this test. Then only you will enjoy yourself, then only you will understand where you stand among all these students. Okay, you need to be competitive right now. आपको अब competitive ही होना है, अब आपको बचना नहीं है competition से, अब आपको competition में कूदना है. तो मेरे भाई इन सारे क्लासेस की जो लिंक मैं शेयर करने वाला हूं वो आगे भी बढ़ा देना, शेयर करना और सबको चैलेंज करना. आओ टेस्ट में बैठते हैं, टेस्ट देखते हैं और देखते हैं कौन कितने पानी में है. ओके, तो बेटा यू हैव टू शेयर ऑल दीज लिंक्स. ओके, चलो. And beta, if you want to see my other lectures, if you want to revise other lectures, if you want to download the lecture notes, you need to just open this link, tinyurl.com/apuroop10. इसको वेब ब्राउजर में खोल लो. Open your web browser and type this tinyurl.com/apuroop10. Everything is well organized here. All my classes are here. Just open this, you will understand everything. And a very important news, beta. Only few days left. 28th of December will be the start of evolve batch and ascend batch. Okay, only 2 days left. Okay, from Monday the evolve batch and ascend batch will start. Okay, so you only have today and tomorrow in order to take the Unacademy Plus subscription using the code Apuroop10. If you are not preparing for GATE 22 and 23, then beta please forward this news to your students, to your juniors who are preparing for 22 and 23, and let them know that they will miss these 2 awesome batches if they don't take the subscription right now and if they don't try this out. Okay, believe me beta, this will be the batch of the year. ये बेस्ट बैच होने वाली है. और अभी क्यों प्रिपरेशन चालू करना है? Why starting the preparation now? Because बेटा अर्ली स्टार्ट विल गिव यू एन कॉम्पिटिटिव एज. आप जितना जल्दी स्टार्ट करोगे आपको उतना ज्यादा एडवांटेज मिलेगा. ओके, सो टेक दिस अर्ली स्टार्ट. जितना पहले चालू करोगे उतना जल्दी आपका कोर्स कंप्लीट होगा, आप उतना ज्यादा प्रैक्टिस कर पाओगे. ओके, so beta, those of you who are preparing for 22 and 23, you need to take this Unacademy Plus subscription right now and join these 2 awesome batches. Only the best of the educators will be teaching in these 2 batches. Okay, जितने educators सिखाने वाले हैं बेटा हर सब्जेक्ट के एक्सपर्ट फैकल्टीज हैं. ओके, तो बेटा Unacademy Plus क्यों Unacademy Plus? ऐसा क्या है Unacademy Plus में जो बाकी जगह नहीं मिल रहा है? कंटेंट तो हर जगह है, फिर Unacademy Plus पे क्यों आना है? तो बेटा कंटेंट हर जगह है, लेकिन कुछ ऐसी चीजें हैं जो आपको सिर्फ प्लस के प्लेटफॉर्म पे मिलेंगे. ओके, अब ये चीज है क्या? ऐसा नहीं है कि बिना इसके आप तैयारी नहीं कर सकते. आप जरूर करिए, आप जरूर पढ़िए, खुद से पढ़िए, आप तैयारी कीजिए. लेकिन होता यह है कि खुद से पढ़ते टाइम कई सारी ऐसी गलतियां होती हैं जो करने से टाइम वेस्ट होता है और हमको बाद में लगता है कि काश मैंने ये गलती नहीं की होती, मेरा टाइम बचता, मैं ये टाइम में कुछ और कर सकता. तो जब आप एक एक्सपर्ट फैकल्टी के अंडर पढ़ते हो कोई सब्जेक्ट, तो आपको ज्यादा सोचना नहीं पड़ता कि क्या पढ़ूं, क्या नहीं पढ़ूं, क्या छोड़ूं, क्या ज्यादा पकड़ूं, किसके कितने क्वेश्चन बनाऊं, किस लेवल के क्वेश्चन बनाऊं. ये सारी जो गाइडेंस है वो एक एक्सपर्ट फैकल्टी की मिल जाती है जिनको ईयर्स ऑफ एक्सपीरियंस है, जिनको सालों का एक्सपीरियंस है, और उनका समझाया हुआ आपको बहुत अच्छी तरह समझ में आ जाएगा, बहुत जल्दी समझ आएगा. और आपको जो नहीं समझ आ रहा है वो डाउट्स आप उनसे पूछ सकते हैं, क्योंकि डाउट सॉल्विंग की यहाँ पे बहुत अच्छी प्रक्रिया है. यहाँ पे डाउट सॉल्विंग के लिए जो चीजें बनाई गई हैं उससे आपको कभी भी कोई भी डाउट आ जाए आप अपना डाउट आराम से सॉल्व करा सकते हैं लाइव क्लास में. ओके, एंड बेटा यहाँ आपको वीकली टेस्ट मिलने वाले हैं इन्हीं एक्सपर्ट फैकल्टीज से. आपको रैंक इंप्रूवमेंट बैच मिलने वाली है, आपको क्रैश कोर्सेज मिलने वाले हैं. तो ये चीजें जो है आपकी रैंक लाने में आपकी जरूर हेल्प करेंगी. मैं ये नहीं बोल रहा हूं कि आप इनके बिना रैंक ला नहीं सकते, लेकिन इस हेल्प से रैंक लाने की प्रोबेबिलिटी बढ़ जाती है. और अगर आपको एक स्टेप और आगे जाना है और ज्यादा हेल्प, पर्सनल लेवल पे हेल्प चाहिए, तो बेटा पर्सनल कोच मिलेगा आपको आइकॉनिक सब्सक्रिप्शन में, जो आपको पर्सनली पुश करेगा आपके गोल की तरफ. आपका डेली शेड्यूल बना के देगा वो, और वो ध्यान देगा कि आप डेली शेड्यूल फॉलो कर रहे हैं कि नहीं कर रहे हैं. वो आपके टेस्ट को एनालाइज करेगा, यानी कहां गलती कर रहे हो, कहां नहीं कर रहे हो, किस जगह पे आप लैक कर रहे हो, ये सारी चीजें पर्सनल लेवल पे वो आपका ख्याल रखेगा. तो अगर आपको और ज्यादा पर्सनल लेवल पे हेल्प चाहिए तो बेटा यू टेक द अनअकैडमी आइकॉनिक सब्सक्रिप्शन. ओके, नाउ व्हाट विल बी द हेल्प ऑन अनअकैडमी प्लस प्लेटफॉर्म? अनअकैडमी प्लस के ऐसे क्या फीचर्स हैं जो आपकी मदद करेंगे? तो बेटा ऐसे बहुत सारे फीचर्स हैं, जैसे लाइव पोलिंग और लीडर बोर्ड, जहां ऑब्जेक्टिव क्वेश्चंस की पोलिंग होती है, जिसमें आपको आपकी रैंक पता चलती है, आपकी टाइमिंग पता चलती है, आपको ऑब्जेक्टिव क्वेश्चन सॉल्व करने में सहायता मिलती है, आपको ऑब्जेक्टिव क्वेश्चन सॉल्व करने की प्रैक्टिस होती है, प्लस टाइम मैनेजमेंट की प्रैक्टिस होती है. ठीक है, फिर इंटरैक्शन इतना लाइव है, आप जो चाहे कमेंट बॉक्स में लिख के टीचर से पूछ सकते हो, या फिर आप अपने क्वेश्चन की इमेज फॉरवर्ड करके भी टीचर से सॉल्व करा सकते हो. और यहाँ डाउट सॉल्विंग सेशंस जो हैं अलग से होते हैं. ठीक है, जो क्लासेस रेगुलर होंगी वो तो होंगी, उसके अलावा हर चौथी क्लास डाउट सॉल्विंग सेशन होगी, जिसमें आपको जितने डाउट पूछने पूछ सकते हैं. तो यहाँ डाउट पूछने के लिए कभी भी टाइम कम नहीं पड़ता है. और यहाँ पे मल्टीपल बैचेस का फायदा है. इतनी सारी बैचेस हैं कि आप जिस बैच में एडमिशन लेना चाहो ले सकते हो. प्लस आपके पास फायदा यह है कि आप मल्टीपल बैचेस में पढ़ सकते हो. मतलब आप ये बैच भी चालू कर सकते हो, देख सकते हो, ये बैच भी, ये बैच भी, ये बैच भी. ये सारी टॉप बैचेस हैं बेटा, टॉप एजुकेटर्स की. ठीक है, मेरी भी बैच पड़ी हुई है गेट 22 की, तो आप गेट 22 के लिए पढ़ सकते हो, 23 के लिए पढ़ सकते हो, आप ESE के लिए पढ़ सकते हो. आपको जिस बैच में पढ़ना है आप पढ़ सकते हो, जिस एजुकेटर से पढ़ना है आप पढ़ सकते हो. दैट इज द फ्लेक्सिबिलिटी यू विल गेट on Unacademy Plus. And all these faculties, let me tell you, have years of experience. They have the best of the best teacher. They are the best of the best teachers in their field. So beta, if you want to take the Unacademy Plus subscription, you have to choose your subscription plan. 1 month से लेके 2 year तक का प्लान अवेलेबल है. लेकिन मैं सजेस्ट करूंगा कि आप 1 ईयर, 1.5 ईयर या 2 ईयर का प्लान लें, क्योंकि एक तो पर मंथ कॉस्ट में बहुत ज्यादा फर्क है, और दूसरा आप जितना लंबा प्लान लोगे आप उतनी ज्यादा बैचेस अटेंड कर सकते हो, उतना ज्यादा ज्ञान आप प्राप्त कर सकते हो। और बेटा अगर आप ये कोड यूज करते हो अप्रूप 10, तो आप 10% ऑफ भी ले सकते हो, मैक्सिमम 10% ऑफ मिलता है, जो कि आप इस कोड को यूज करके ले सकते हो। आप कोई भी कोड यूज कर सकते हो, बट ये कोड यूज करने से फायदा क्या होगा बेटा, अगर आप ये कोड यूज कर रहे हो मतलब मुझे ऐसा लगेगा जैसे आप मुझ पे भरोसा कर रहे हो, क्योंकि मेरी ऐप में भी मेरे को नोटिफिकेशन आएगा दैट यू हैव यूज्ड दिस कोड। एंड बेटा अगर मुझे ऐसा लगता है कि आप मुझ पे भरोसा करते हो तो फिर वो भरोसा मैं क्यों तोड़ूंगा। तो मैं आपको पर्सनल लेवल पे जितना हेल्प कर सकता हूं करूंगा, जितना गाइडेंस दे सकता हूं, जितना मोटिवेट कर सकता हूं, जितना मेंटर कर सकता हूं मैं करूंगा, और मैं चाहूंगा कि आप मेरे साथ अपनी पूरी प्रिपरेशन कंप्लीट करें। ओके, एंड बेटा आप ये जो फी है ये नो कॉस्ट ईएमआई पे भर सकते हो, यानी कि बिना किसी एडिशनल कॉस्ट के आप ये भर सकते हो। ओके, पर मंथ कॉस्ट देखो बेटा, अगर आप इस पर मंथ कॉस्ट को कैलकुलेट करो पर डे कॉस्ट पे, तो बेटा ये वाली कॉस्ट जो आएगी 74 रुपीज पर डे आएगी, दिस विल बी 64 रुपीज पर डे, एंड दिस विल बी 54 रुपीज पर डे। ओके, सो you can imagine how affordable this is, how affordable this quality of education is. इमेजिन ये सारे धुरंधर, ये सारे लेजेंडरी टीचर आपको पढ़ा रहे हैं सिर्फ इस कॉस्ट पे। तो अगर आपको लगता है कि आप इतना अफोर्ड कर सकते हो पर डे, ये ऐसी चीज है बेटा जिसपे आप बिना चाहे भी आप 70 रुपए 50 रुपए जो है बिना चाहे डेली बेसिस पे खर्च करते हो उल्टी सीधी चीजों पे। तो अगर आपको लगता है आप उन चीजों की बजाय अपनी एजुकेशन के ऊपर ये पैसा खर्च करने के लिए तैयार हो, तो बेटा प्लीज टेक द सब्सक्रिप्शन राइट नाउ एंड ज्वाइन दिस रेवोल्यूशन अनअकैडमी प्लस and join these legendary batches, Ascent batch and Evolve batch starting from 28th of December. Okay, you can take the iconic subscription also. 1 year की फी इतनी है, 2 year की फी इतनी है। iconic subscription के लिए भी you can use the same code and you can also take this iconic subscription on EMI. Okay, तो यहाँ आपको एक personal level पे help मिल जाती है। Okay, so I will see you soon on these batches बेटा। Till then, please hit the like button, please share this link and subscribe to this channel. Thank you so much for watching. I will see you tomorrow at 9 AM for the marathon session. Till then, bye bye, take care, good night.